Hi, welcome to our video on arithmetic sequences presented by 3Math Guys. Please subscribe, visit our website at 3mathguys.com. All right, so if you've got a sequence, which is basically just a list of numbers, and typically they've got some kind of a pattern to it, how do you tell if that sequence is what we call arithmetic? And you're really looking for couple things. You're just looking for, is it adding or subtracting by the same amount over and over. So if you look at this first sequence that we've got, you can probably already tell if you look at it for a second, what's this next number going to be? And you can probably tell it's going to be 13. If you notice the pattern, that it's going up by 2. So this is going plus 2, plus 2, plus 2 over and over. And by adding by the same amount over and over, that makes it arithmetic. Or if it's subtracted by the same amount, that would be true also. So let's look at our second sequence and decide, is this an arithmetic sequence or maybe some other kind of pattern? So you'll notice the 8, 12, 16, it's changing by 4. Don't mix up your positives and negatives. Is this going up by 4 or down by 4? Might help to think of a number line. And so this is actually going down by 4, subtracting by 4, over and over and over. And so that meets the definition of something that would be arithmetic. So this one is also arithmetic. Check, check. All right, let's look at the third one here. And obviously our next number would be what? Minus 24. So 3, 6, 12, 24. Can you tell what the next number would be? You probably can. We'll be at 48. And how are we doing that? Times 2, times 2, times 2, right? But that sequence is a little different pattern than what we have up above. These are adding or subtracting by the same amount. This one's multiplying by the same amount, which is not something we call arithmetic. That's a different type of sequence. So really, if it's arithmetic, we're looking for something that we call a common difference. Common difference. And it's called a common difference because if you had a more complicated one and you were having trouble seeing it, how could I find that 2? Well, 2 is what I get when I take 5 minus 3. And when you subtract, that's called the difference. So the difference between 7 and 5 is 2. Between 9 and 7 is 2. So that's the common difference. These have a common difference of plus 2. Okay. This one has a common difference also. If I took negative 12 minus negative 8, I would end up with negative 4. So this one would have a common difference of negative 4. Where on this one, times 2 is not a common difference. If I do 6 minus 3, I get 3. And if I take 12 minus 6, I get 6. So 3 and 6 would not be a common difference. So this doesn't meet the pattern. So hopefully that gives you kind of an idea, what are we looking for when it's arithmetic. Okay, so let's look at a couple more. Are these sequences going to be arithmetic or maybe some other pattern? So I'll give you a second to kind of look and see what that next number might be. And this one, let's kind of take a look. I mean, what's the difference? How do we go from a 4 to a 6? Well, there's a couple ways, but one way to do it is to add 2. But then if I keep adding 2, I should have an 8, not a 9. I'd have to go plus 3, then plus 4, plus 5. So if the pattern continued, I would add 6 and be at 24, right? But that's not going to be what we call a common difference. These differences are not the same as each other. So this one is not going to be arithmetic. It does have a pattern, but this sequence would not be arithmetic. All right, what about this next one? 2/3, 4/3, 2, 8/3. Looks a little different. And I'll give you a hint that I give my students here. One way to look at this, if you've got fractions in your sequence, is to give them a common denominator. If you can see the pattern without that, then great. But if you're having trouble finding a pattern, I could write this, 2 is really 2 over 1. Can I turn that into a fraction that has a 3 as a denominator? Sure. 1 times 3, so 2 times 3 would be 6/3. And if I change it to this, 6/3, and I do the same thing over here and I call this 12/3, then the pattern's easier to see. I've got 2/3, 4/3, 6, 8, 10, 12. So the next one's going to be 14/3, and then 16/3, and then 18/3, but that one will reduce down to a 6. Okay, So does this meet the pattern? Yeah, it's going plus 2/3 every time. And since it has that common difference every time, it's going to be arithmetic. So yes, that one's arithmetic. Okay, so let's do a couple more real quick. On this next one, you might see what the pattern is doing here. But if you had trouble, you could kind of go through it the formal way and say, well, let's look for a common difference here. Let's take 3.6 and subtract 4.8 and see if that answer is the same that we get when we take 2.4 minus 3.6. You can do that on a calculator, do it by hand. But you might notice the pattern that it is going down by the same amount over and over and over. It's going down by 1.2, down by 1.2, and so on. So this one's going to end up being negative 1.2, negative 2.4, and so on. So yes, this one is arithmetic. It adds or subtracts by the same amount. Okay, well, let's look at the last one here. This one's a little trickier. It's got fractions, and so can you see the pattern happening and tell what would come next? We've got some whole numbers mixed in with the fractions. And again, let's use that trick of if there's fractions involved, let's see if we can get these to all have a common denominator. And that's if you're having trouble seeing the pattern. So 5 can be written as a fraction, something over 4, right? And wouldn't it be 20 over 4? 20 divided by 4 is 5. And then I have 21 over 4. And then if I was going to write 11 over 2 with a 4, well, I'd have to go times 2 times 2, and I get 22 over 4, 23 over 4, and you might start seeing that this pattern is a lot easier to follow than it initially seemed. So can you tell what's next? 20, 21, 22? Well, it's just going to obviously be 26 over 4, but I could reduce that. They're both even numbers, so I'll have 13 over 2. The next number is going to be 27 over 4, then 28 over 4, which 28 divided by 4 is actually 7, so we could just call that one a 7. But it is changing by a common difference. So this is actually adding by, well, by how much? It's going plus 1 on the numerator, and these are all fourths, so it's going up 1/4 every time, plus 1/4. And hopefully that gives you an idea, how do I tell if something is arithmetic, okay?